Continuing on with congruent figures, we have an example here. We have to determine which of these could be congruent to the above parallelogram. Okay, so in all of these, we see that we're using the angles, and some of them have kind of this angle with a tick mark 1, and some of them have angle with a 2 tick mark. Okay, but if we look at all of our figures, each of them has those. Okay, they all have the angle with 1 tick mark and the angle with 2 tick marks. Okay, so the very first thing before we can say that these two figures are congruent is, again, we have to make sure, judging by our rules from before, or the stipulations, they have to have the same amount of sides. Well, obviously, this one has 4 sides. This one only has 3 sides. So even though they have some of the same angles, we know for sure it's not going to be A. Okay, it does not have the same amount of sides, so it can't be a congruent figure. Okay, the next thing we have to check for is that the corresponding sides are of equal length. Well, they didn't tell us anything about the length of these sides, so that really doesn't help us any. So the last thing that we have to check is that the corresponding interior angles are equal. And when we say that they correspond, they have to be in the same spots too. So notice how, if we look at this one, it has 1 tick mark. The one right next to it on either side, on both sides of it, has 2. Okay? And then the one across from it has just a 1. So if we look at this one, it has a 1 tick mark. The one next to it over here has 2, but the one next to it on this side only has 1. So even though they have equivalent or congruent angles, they don't match up. Okay? This one has, it's like the 2 tick marks, 1 and 1 in each of its corners. It should have 1, 2, then 1, then 2. Okay, so it should kind of go in that pattern. So the only one that does that is this piece. Okay, and again, in this case, it should be pretty obvious. We should be able just to look at it and say, well, that's the shape that is exactly the same. But that's what we're looking for, is kind of that given information, using which angles are going to be congruent to each other and which sides are going to be congruent to each other. Even if they didn't, in this case, again, they didn't give us the sides. Okay, going on to our next example then. Okay, they started with a congruency statement. They're telling us that A, B, C, D, E, F, that's this piece, and G, H, I, J, K, L, that's this piece, are congruent. Which side then is congruent to the side CD? Well, remember from our congruency statements, everything has to match. Okay, so right now, if you look at it, we have kind of a little piece in our bottom left, and it looks like we have a little piece in our bottom right. Same thing, little piece at the top right, little piece at the top right. So at first glance, it might look like these are already the exact same. They're already in the same spot. But actually, if we look at these, this one down here is actually longer than this one up here. And it's actually flipped over here. This one is longer than this one. So actually, although it looks like these ones might be in the same spot, one of these is actually rotated from where it was supposed to be. They don't actually match. Okay? How we know that they don't match is, again, the congruency statement told us which ones match with which. Okay? A was first and G was first. So A right here actually matches with G. The next one was B and H. So B here actually matches with H. Same thing. C actually matches with the third one, I. Okay, and so on. So you can see that it's actually kind of rotated or flipped all the way around. And we need to make sure that we match up each piece with its correct spot. So now that we know that we're kind of flipped over, we're trying to match this side CD. CD is these two right in the middle, so we know that it has to be these two right in the middle. Okay, we can look and say this side CD right here. If we kind of flipped things around and got everything into their place, it would actually be this side. over here. So we would have to say that CD is actually congruent to IJ. IJ is actually the side that's going to be congruent there. CPCTC. Sometimes you'll hear it said CPCTE. Basically what that spells out, or what those letters stand for, are corresponding parts of congruent triangles are congruent. And if somebody said it with the E, what they're trying to say here, that E stands for equivalent. Equivalent. So again, it basically just says if we have figures or polygons, triangles, whatever it is, and we said that this one is congruent to this one, then again, all of their pieces are going to be congruent to each other or equivalent to each other. Okay? So again, if we start with this triangle, A to B to C, and it's congruent to this triangle over here. Okay, now we don't necessarily know which order it goes in yet, but if we look at it, we can see that we've got this one swoop angle with this one swoop angle. So those angles are going to be equivalent to each other or congruent. This one has 2, this one has 2. So those two are equivalent to each other. This one has 3, this one has 3. Okay, so looking at all of our pieces, once we know that these two triangles are congruent to each other, we can say these 6 things. Okay, angle A is congruent to D, angle B is congruent to angle F, angle C is congruent to angle E, AB, so this segment is congruent to DF, it's actually the same as this one down here. AC, so going from here to here, is the same as D to E, and B to C, this one, is the same as F to E. Okay, so they actually kind of drew that all on there and showed you each piece. But again, that's just if we were just told these two triangles are equivalent or are congruent, we would know automatically all of this information. Okay, so again, just as kind of a double check, the congruency statement is ABC is congruent to DFE. Okay, it would not be DEF, it's DFE, because you need to make sure that they match with the ones that the picture is showing. B, our second letter, has to match up with F, because they both have the 2 angle marks there. Those ones are equivalent to each other. The isosceles triangle theorem, again, that one should be reviewed. We did that last unit. Basically just says if the 2 sides of a triangle are congruent, so if I told you this side is congruent to this side, then you would know for sure this angle has to be congruent to this angle. They have to be the same. So if I gave you a triangle and I said that this is 5 feet, this is 5 feet, you would know that whatever this angle is, this angle has to be the same measure. Okay, so that's like the regular, that's the first part of the isosceles triangle theorem. Now we also learned about converses before. Not all converses are true, but in this case, the converse of the isosceles triangle theorem is also true. Okay, and it says if 2 angles of a triangle are congruent, then the sides opposite are congruent. So if I know that this is the same measure as this, then again, I know for sure this one has to be this one. So as an example, if I gave you this triangle and I said that this was 23 degrees and this was 23 degrees, then you would know this side has to be the same as this side every single time. Okay, using that information then, we have 2 last examples here. We need to solve for x in this case. We are given a triangle, XYZ, and again, it gave us these little swoops here saying that these 2 angles are going to be congruent to each other. Okay, what does that tell us? Well, it tells us that these 2 sides are congruent to each other. So using that information, we can say that 15 equals 4x plus 3. Okay, at that point then, I would just subtract 3 from both sides. I would be left with 12 equals 4x. I could divide both sides by 4, and that would leave me with 3 equals x. So that's how we would solve for x in that case. In this example, we have to solve for x and y. Okay? And again, they gave us this information. This side is equal to this side. So we know for sure this angle is equal to this angle. They have to be the same amount, or the same measure. Okay, using that information, I just set the left angle, 3x minus 11, equal to the right angle, 2x plus 11. Okay, using that information, if I add 11 to both sides, so actually I'm going to write that in, I'm adding 11 here and adding 11 here, we would get 3x equals 2x plus 22. Next thing I would do is subtract 2x from both sides, and that would leave me with just x equals 22. So at that point, we've already solved for our x value. Okay, now to solve for y. This piece here is 2y. And we know some things about triangles. We know that all of the angles added up have to be 180 degrees. Okay, so before we can do anything else, we have to find out how big this angle and this angle are. And all we have to do is just plug in x. So, and what we're doing is just saying 3 times x, or 3 times 22, minus 11 is going to give us this angle over here. And 2 times x, or 2 times 22, plus 11, that'll be this angle right here. Now hopefully both of them will equal the same, because again, this is an isosceles triangle. This side equals this side, so that angle has to equal that angle. So they should come out to the same number. And if we do the math, we figure it out, indeed, they both come out to 55. So using that information then, we just set everything up, say 55 plus 2y, or each of these angles. If we add them all up, we have to equal 180. Simplifying, we can just take 55 and combine them together. That would be 110. So we have 2y plus 110 equals 180. We can subtract 110 from both sides. So we'd have 2y equals 70. And the last thing we need to do is divide both sides by 2 to get y alone. We'd have y equals 35. So at that point, we've solved for both x and y. And that's going to conclude our first section.